Hey guys, Coach Moss here. So we're going to continue on 4.1 talking about logarithmic properties. I actually really enjoyed this aspect of logs, and I'm hoping that you will too. Let's talk a little bit about the definition of the logarithm with base b. So given this information here, we will be able to solve all of these equations for the value of x that we're missing. All right, I went ahead and put an x in each of these spots. It wasn't there before, but it's definitely going to help you visualize. So we have log of b times y, log b of y. So in this case would be log 4 of 16 is equal to x if b of x equals y. So you're going to take whatever the base of the log is, and you're going to put it to the power of the x and set it equal to whatever your whole number is. All right, so in this case, I would take 4 to the x is equal to 16. And we can do a little mental math here to know that x is going to be equal to 2 because 4 squared is going to be equal to 16. Now, these are very, very simple. We're going to go through a few of these, and then I may leave one or two for you to try. So let's move on to the next one. We have 1/4 to the power of x is equal to 4. Now, I know that in order to take a fraction and make it whole, we would have to have a negative exponent. And it would be the same if we were trying to take 4 to the x power and make it 1/4. We would, again, if we're flipping it whole to a fraction or fraction to a whole, it's going to have to be a negative exponent. And in our case, our basis is still the same. If this were like 16, it'd be a -2. But since we're keeping it 4, it's just going to be -1. All right, and now let's look at this one. We have 1 to the 81 to the power of x is equal to 3. And again, oh no, I did that wrong. Whoopsie. A simple little mistake can go a long way. Okay, 3 to the x is equal to 1 over 81. And again, here I am saying that we're taking a whole number and we're trying to turn it into a fraction. So you can think of whatever the power is to make 3 become 81. Which would be 4, but because we're taking a whole number and making it a fraction, it's going to have to be negative. Okay, so let's take 25 to the x and make it 5. Okay, in order for us to get 25 and make 5, our fraction, we know that the square root of 25 would be 5, and that would mean that x would have to be 1/2. All right, you're going to see several variations here. We've got some negative x values. We have some fractions of x values. If you are taking a large number and trying to make it smaller, majority of the time it's going to be 1/2, maybe 1/3 if it's a cube root, but they'll always be solvable that way. So if you're taking a whole number and like a larger number and trying to make it smaller, try to take the square root or the cube root and see if that gives you the number that you're looking for. All right, let's talk about this one down here. We have 7 to the x equals 1. The only exponent that can take any number and give you the answer of 1 would be x equals 0. All right, let's look at number 6 over here. We have 5 to the x is equal to the square root of 5. I know that this is also 5 to the x is equal to 5 to the 1/2. Okay, so that would mean that our x is going to be 1/2. All right, let's look here. Oh, we have 0 to the x is equal to, oh, I'm sorry, whoops, I keep doing that. So this is why it's good to practice. 3 to the x is equal to 0. No value for x will give us the answer of 0. This one is going to be one that does not exist. Anytime you have an exponent and it's supposed to give you the answer of 0, unless this 3 is a 0, we will not be able to find that answer, so it does not exist. All right, let's look at this one over here. So I'm actually going to move my 16 over. Well, I'm going to rewrite it. Actually, we're just going to leave this as a -16. So this is all together. So we have 4 to the x is equal to -16. All right, again, this one is going to be does not exist. No exponent can give us the answer of a negative number here, because of course, any negative x value would produce a fraction. All right, let's talk about what if there was not an easy answer. You would have to use the calculator. All right, so for this one, we're still going to write it the correct way. I'm still going to change the way that it looks, but yes, you would have to use a calculator for these. So this would become 3, because this is an x, sorry. 3 to the x is equal to 16. Using a calculator, you could plug this in, and we would find the approximate x value to be 2.52. I'm just going to round here, guys. All right, and I'm still writing in that form because every time you do this, you're probably going to want to do that just to be sure. 2 to the x is equal to 28. There's no way for us to know because we can't square it, cube it, or go to the 4th power to get 28. It's going to, once we plug this into the calculator, our x value is going to be around 4.8. You can guesstimate. We know that it should be between 4 and 5, but we don't know exactly what it's going to be unless we plug it in. So again, we have this here. We've got 4 to the x is equal to 17. Now I know that 4 squared is 16. So our value is going to be somewhere around 2, a little bit more than 2. And in this case, it's actually 2.044, somewhere around there. All right, here we have 5 to the x is equal to 50. I know that 5 squared is 25, and then 5 cubed is 125, so it's going to be between 2 and 3, probably closer to 2, and when we solve, it's actually 2.431 when you are using a calculator. All right, down here it talks about natural logs and base e. The natural log is going to be ln, and then the exponential form is e to the x, which is equal to y. All right, so let's move on to properties of logarithms. I'm actually going to make a new video.